Welcome everyone to our deep dive into Python. Today we're going to explore in depth why the Python language is not just a tool, but a foundational element in the world of data science. So let's first start by understanding Python. It was created by Guido van Rossum and released in 1991. So Python's design philosophy emphasizes code readability, which is achieved through its use of significant white space instead of curly braces. And the language supports dynamic typing and automatic memory management, which are important for rapid development and scripting. Also, uh, unlike other languages, Python has an extensive standard library, uh, which is considered as its most powerful assets. So Python is renowned for its simplicity and readability. Its syntax often is very intuitive and similar to the English language. So people who are new to programming languages and programming, it's making it more accessible. And this emphasis on simplicity often reduces the initial programming overhead, uh, which allows for a focus on solving problems rather than trying to understand and write code. We'll later look at some examples that highlights Python's readability and discuss how this impacts the learning curve and development speed in data science. So Python's true strength lies in extensive libraries and framework. And each libraries and framework, they are tailored for specific aspects of data science. We'll look into how Pandas library revolutionized data manipulation and how NumPy facilitates numerical computation, and we'll also look at the role of SciPy in advanced statistical analysis, and we'll also explore machine learning with scikit-learn, deep learning with TensorFlow and PyTorch, and data visualization with Matplotlib and Seaborn. So Python is backed by a thriving global community, and this community plays a key role in contributing to and maintaining uh, the vast amount of open source libraries. We'll look into how this ecosystem works, including how regular updates and improvements are made. We'll also discuss the um, importance of some of the forums, uh, meetups, of like knowledge exchange, and the uh, abundance of learning resources and tutorials available online. So Python excels in integration, scalability, and performance. We'll look into Python's interoperability with other programming languages and tools, and its capability to handle large data sets and complex computations, and its widespread use in both academic research and industrial application. Also, we will look into performance optimizations in Python and discuss its limitation. So Python isn't just for basic data analysis. We might not be able to cover much in regular data science course, but it's the Python is at the forefront of cutting edge data science applications, and we'll briefly look at how Python is used in machine learning for algorithms and data pre-processing, and in deep learning architectures with like TensorFlow and PyTorch, and in natural language processing for tasks like sentiment analysis. We'll also kind of look at real world case studies showing Python in action. Lastly, we'll look into how tools like Jupyter Notebooks are revolutionizing collaboration in data science, and we'll emphasize the importance of reproducibility in scientific research and explore Python's evolving role in emerging technologies. Lastly, we'll kind of look at future trends and development in Python for data science. So in conclusion, Python is central to modern data science practices. It's a language that continuously evolves alongside field. Python recently had a new release, making it an indispensable tool for any data scientist.